It's like almost working. But the best what we can get, okay? So slideshow, present a view. One for you, one for me. This one is for you. I not have to. Yeah, I nailed it. And view. Hide the toolbar. And we are ready to go after all this disturbance. Hi, I'm Piotr. I work at, as it said, at Allegro, as senior security specialist, where I handle mostly security of a cloud and AI projects. In the spare time, I'm making my best to finish my PhD, which is also in the threat modeling field, in the security engineering field of science. So the agenda. We will start with a little bit of theory. And after the theory, we will go to the, I make it bigger. Oh. We'll go to the field examples, two different studies with two different circumstances. I want to uncover some threats, threat modeling secrets straight from our kitchen from Allegro. Basically, I want to show you in example how we made our Kung Fu stronger with threat modeling. At first, we'll do some recap. As I said, the theory, and then we'll dive into the birth of the formal threat process in Allegro. And in the second case, we will uncover how we handle the AI projects. So threat modeling. It's not the most sexy subject in IT, nor in security, nor is the most popular. However, it's strongly beneficial. So I have few warmer questions to you. Just raise your hand. How many of you heard about threat modeling before? Yeah, almost all of you. That's quite wow. And another question, just raise your hand if you totally agree with the following statement. In my organization, threat modeling is a standard practice, what we are doing on a daily basis. And not so well, yeah? I hope I convince you to change your businesses, and next time all raise hands. So what is threat modeling at all? Threat modeling is just a structured process where aim at identifying and evaluating and addressing potential threats to a system. So it's a process that is proactive, not retroactive. We are addressing vulnerabilities and other threats before they are materialized in our products. We aim to understand how attacker could exploit our vulnerabilities to compromise assets, systems, and data, and we address them before production. So this is the main idea of threat modeling. So threat modeling is a process that is essential for survivor. It is very hard to point out where threat modeling started. It could be found in some form in first computer science curriculums from 1960. I personally found the paper stating that the first formal threat modeling was done in computer security threat monitoring and surveillance by James P. Anderson in 1980. But it was based on the concepts from earlier work, structured design. First popular methodology called STRIDE was made by public by Microsoft in 1999, but sadly I don't find any information of who is really behind the STRIDE. There is only names behind the publication of the STRIDE, which is stating that STRIDE is a well addressed methodology in Microsoft and well adopted in 1999. STRIDE is an acronym naming dimension in which assessment is done, which follows spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, but we won't jump any further into well-documented methodologies. We will jump all the way to adoption. And if you want to learn more about methodologies, I will show the Intel on the last slide. where you can find the informations that will suit you with the process start if you are on the beginning on your track to threat modeling. So, last thing from the theory, we need to speak same language, and I found it really confusing in most of papers, where there is hard inconsistency in naming. So I written down some definitions, but look closely for a second on the doc. A vulnerability is a property of a system that allows dog to bite leash, which can be overbitten. The threat is the attack of the dog on us. The attack would be the act of someone destroying the mitigation mechanism, which is the cutting the leash, for example. The threat will be the act of dog attacking us. And the hazard is the potential that dog has on us. So it's kind of harmful that it can attack us in some incrustations. So we will not cover risk assessment today. It is crucial to understand that threat modeling is not a risk analysis. Unlike risk analysis, which assesses the probability of threats, threat modeling focuses on identifying and mitigating potential threats directly, without considering the likelihood. Keep also in mind that even the best probability assessment would not have effect on the actual risk materialization. For engineers like me, staying practical is a key. While risk assessment have their place in management, this might not always be not always meet our day-to-day needs. We must be prepared to highly unlikely events. So let's hop straight to the meat. So the journey starts with the threat modeling assessment in beginning of 2022. One of colleagues was joining our team for a quarter in project called internal tourism. He was just a front-end developer. He wanted to have some experience with IT security. We thought that threat modeling would be a good idea because we didn't do anything with this matter before. And my colleague, Piotr Żabrowski, took lead in this project when the journey starts. So we want to make sure that S in our SDLC stands for secure software, not software alone. We also want to stop saying about security by design and just design the software securely. I'm not saying that we had no security controls in place, but adding another one seems like a good idea. Shifting LED was not only a good idea, but was the main need. This is the only way that we can succeed in threat modeling, because we need the biggest security team in our company, and the team is called the developers. Putting responsibility in hands of developers have also quite nice side effect. We are building culture of responsibility for security, where all parties participate in success. Outcomes from threat modeling also are great input to other processes like compliance analysis or risk analysis. So we thought it would be beneficial to deploy such process. And we already have a static application security testing, which we done ourselves, a solution, but adding another tool will be a great idea to close the gap, which we identified. We have some requirements. We thought it not have to be time-consuming for the developers. It should be easy to use, and it should have be embedded in our processes. So we don't need putting entry for the another processes and make things even more complicated for our developers. We need to keep it simple. But we didn't have much experience with threat modeling, and we start researching the market. We tried to find any other companies that deals with the threat modeling at scale, but we fail miserably. It looked like no one is doing it, or at least no one is sharing the knowledge. So we focus on methods and tools that were available, and it was something. really something. We find some tools, but we have a huge problem. All these tools, techniques, require a committee of people to sit, talk, draw, and finally identify threats. And this is time consuming. We have over 2,000 microservices and even more developers, not mentioning infrastructure, AI, data systems, solutions like OWASP Threat Dragon and other methodologies embedded in this tool was not a way for us, was not scalable enough and didn't fit our needs. Basically, any other tool is even more complex or needs special annotation in code, which is even more time consuming. We were kind of disappointed at this stage, but we wanted to start something and see what happened next. You know, all services are somehow similar. They take some data, process it, and save the result. Some process user-controlled data, some don't. Some have public API, and some don't. I think you take the drill. We look also out at previous reports from vulnerabilities, from our own test, from our bug bounty problem, and external penetration test reports. We had done some data exploration and matched the vulnerabilities with the OWASP top 10. And we came up with something with a form of the questions. So on the second stage, with this question written in Excel, we continue our work in more structured way. We invited 20 development teams and sit down with them and talk about their services, threats, mitigations, vulnerabilities, and past and overall process of the daily development. And walk through threat modeling with our mockup, with our Excel. We got some feedback. We know which questions we need to reformulate and which we could drop. And we have our first success. We found with this tool mockup our first vulnerabilities, but it was high severity one, but I can't share your details with you. After analyzing transcripts and notes from the meetings, we have a tool mockup. It is really easy. We have our services. We divide them into several areas. The areas, you can think about them as attack surfaces. And to each area, we add some question sets that was identifying some threats and addressing some threats. Some questions were only closed, so it is yes or no question, and some led to another question set to take more precise notes and more precise identify threats, potential threats in the services. So with this structure, we got a plan. At this stage, we decided to make the threat modeling very simple, meaning we want to ask a bunch of questions with only yes or no answer. And no is always cutting the tree, and yes can lead to another question set or lead to a potential vulnerability. And with the potential vulnerability, where the potential vulnerability is identified, we have some guides to address the threats in our product. We find out that our static application and security testing tool was scanning all services. And so we decided to use it as threat modeling. The tool scan starting after merge pull request to the main branch. We added check which scan if service had threat modeling done at least once. If not, developer was notified to do so. Developer then went to threat modeling service where it was possible to fill the form and get a list of given services and the threats. But we decided that threat modeling will stay optional for the developers. And they will see the benefits, and eventually all will naturally flow to the process. So this is the plan. And we got final product. Every team from the idea to deploying such a service took us about 6 months. The solution works to this day, and it's easy to use. I don't know if there is any other, or is it one of its kind. At least I didn't find anything similar. You can easily make something similar, even no code, with Google Forms, Microsoft Forms, bunch of app script or Power Apps for the presentation of results. So it starts with some questions, some basic questions, which then open the trees for the vulnerabilities in detail later. So this is for the front end. You can see that there are a bunch of questions that are only yes or no. Is a sign-in required, and so on and so on. So after filing this, you can find the report with vulnerabilities to explore and to learn from it. And developers can only open the quick view or go to the really through threat modeling instructions with code snippets and examples. So what are cons of this approach? A set of questions. It's specific to Allegro from the one point of time, and this is the main reason I'm not sharing it right now. It is only useful for us because it's made on our stack. The process is not starting in early development by default, and it is not universal nor versatile. But the process is common, and this is really pros. It is easy, it is fast, it works really good for us because it was made for us on our vulnerabilities, and there is simple KPI for it. So participation percentage. And up to another example. So we are now in the early 2023. At the beginning, when the boom on the AI have created very present need. We need to enable structured process for a large scale of Gen AI-based projects. The core of it had to be security by design. We have huge legal uncertainty, which continue to this day, by the way. However, requirements from the regulator are still unknown. Since last winter research was done last year, I decided to redone the research, and maybe there was be some progress on it, and I found some really cool stuff on AI risk and threat modeling frameworks, like Google's Secure AI framework, Stride AI, so implementation for Stride, or Plot for AI, which is threat library for AI projects. And also Threat Modeling Manifesto was really good, great help for me. So as you can see, the most of the literature is in gray area. There is no significant amount of peer-reviewed document papers. So there is also always a huge field for research. So first I need to deepen my knowledge of current plans for AI. So I scheduled myself for interviews with data scientists. I need to find also out how many they know about threat modeling right now. Maybe they are doing threat modeling in the informal process. So after the research, I had some decisions that I made. First of the decision was freedom over standardization. I had to cover very different projects, all from the LLM, so large language models, large multimodal models, image generation, stable diffusion, and which also are backed in different technologies. Some are semantic kernel, some is LangChain, some are only DAX from Airflow, some use tools like DSPy, and so on and so on. And each developer had different idea, different approach on the AI, mainly. And the concerns were also pretty different from the technological standpoint. There was concern about human rights, compliance, privacy, even the safety of the implementation in some cases. That's security, safety. So I choose to went to freedom over standardization. So the process will be not as standardized as it is in the previous case. So I will give developers freedom to choose the methodology, and I test that later. I will talk about testing it later, this approach. So I give the freedom. But the most important thing in threat modeling is do it at threat modeling. So I decided to do some experiments. So I test quite a few methodology. I schedule myself with the data scientist teams as a facilitator. I was just building them up through the methodology they use. I tested Stride, Plot for AI, CIA, Linden, Red, ADAC trees, and many, many more. And I found out few things. First of all, no matter what methodology you choose, there is always benefit from the threat modeling. There is always some vulnerabilities to uncover. There's always something that you need to address on the design stage. And we also choose that we will use the data flow diagrams for our application map. But also, this led me to another decision. I made threat modeling, which is kind of risky decision. I make it mandatory for all AI projects. And why I did it? I have one strong reason. The threat models were highly useful for security tests. And also the vulnerabilities that were addressed in the design stage are really, really cheaper to address than in the full application. So this is how we address it. And I said that we use OWASP Threat Dragon as an optional tool, and we stayed it as an optional tool because some developers choose really not to use Threat Dragon. They want to draw it and draw it on some other tool that they will use to do, because most of the work, I found out that the most of the work was done before in some other processes, in some other needs. Some was for the process cards, some for the other processes. So I finally came up with the process design for the threat models in AI. But also I found a really pressing need for education and for the knowledge and I had to provide knowledge to the developers, to the teams, and to the product teams. So I decided to write a book on threat modeling because I didn't find anything that would suit our needs on the market. So I wrote down the guidebook on threat modeling and make it available in our internal network. And it's really, really useful to this day. So we decided on simple steps. First, developers had to learn on the threats, on the potential threats. Read at least OWASP Top 10 for LLM, which was write, by the way, a draft on the time when I was writing the guidebook. It was not a ready solution. So first of all, you need to educate yourself on the threat intelligence. Do some threat intelligence, find what is concerned for your application, then get in touch with the expert that can back you up. In our case, this is my team, so IT Security, Cyber and Defense Offense team, which is backing you up, which is helping you with the whole threat modeling, in the whole threat modeling process. Now, on the next stage, you have to create data flow diagram of your service. We recommend to do this in ThreatDragon, but as I said, it is not a mandatory step. So with this ThreatDragon, you need, when you know what you are dealing with, you know what your application will do, you know how it will do. It can be rough on edges, but you know what you are doing. So you need to get diverse team to do the threat modeling brainstorming. And by diverse, I mean different roles in teams and teams. So you have to invite some colleagues from other team to have fresh look on your application, and this was really beneficial. It's also diverse, but not huge. Up to six we recommend in our processes up to 6 people to doing a threat modeling exercise, because if bigger teams seems to be less efficient in threat modeling and do not perform better. Then we encourage the teams to assume compromise on each element of the system. So we are encouraging them to find what would happen when each element, each part of the system will fail in the way that is not foreseeable. We are just making it fail and not assuming why. And we are testing what will happen if the part is gone in some way. With this and with a data flow diagram, we are doing threat modeling session with the framework of choice. It could be Stride, but most popular is the Plot for AI, which is really simple and close. It's really one of the fastest to do. And after threat modeling session, you need to address all threats. So you need to go to your code and remediate the vulnerabilities. And implement it, remediation mechanism in the process. If you find something that is non-remediatable, or you don't know how to approach this vulnerability, you can either contact the cyber defense and offense team and seek help with us, or report them as a risk. And this is different process for the risk management, risk assessment. And this is how this is working, but it's not all. We have training and support for the teams. We are actually doing presentations with the developers, and we found out that this is really useful, and it worked like a charm. Before the presentation, threat models are not ideal, to be honest. And after training, threat models seems to be better. And there is one big anti-pattern that the training is really good to resolve. One-man army anti-pattern, I mean. So there is a strong tendency to source all the threat modeling to one-man army, the threat model genie, that will handle all threat modeling for the team, and he's the one that will do all the work. And it is strong anti-pattern, because one man with this approach, one man has not the broad enough view on the project to identify all the threats and do it properly. We're also waiting to be included in the threat modeling session. So yeah. And what are the cons of this approach? First of all, it is harder for us and harder for everyone to work with non-standardized threat models, because the people throw us documents in many non-standardized formats. So this is harder, it is consuming more time. The threat modeling session and the threat modeling process is taking significant time. Threat models from the start to finish took about 6 to 8 hours. And this is pretty significant if you think about the man-day cost of the developer. And the learning curve is sharp, yeah, but the training is needed. Developers, data scientists are not infused with the knowledge from the start, from their experience. The pros: we are doing actually more and more valuable threat models. We are identifying more and more vulnerabilities in the early stage. The process is really flexible. We can cover much more technologies, and we are ready to adopt to new projects, new technologies, and new products. And the process is really creative. So we don't need to do any library maintenance on threat models. Yes, so we don't have a need to go through our vulnerabilities and do the refinement from the time to time, as it's with our first approach. But these two approaches on threat modeling are alive and good going in our company right now. So what's next? What are our plans? First of all, I need to finish my study. I'm actually right now doing the structural literature review, which is really time consuming, but I think it will be worth it. So the next was the huge gap that we have and that we didn't talk about in this whole presentation. The biggest gap is that we don't have a way to automate the process. It is always based on the human workload. There is no process to automate it. But why is that? Why we had no way to automate it? Why is no good way to automate it? Because there is no methodology that is capable of handling automation. North Stride, Linden, Plot4AI are best suited for the automation. So we need to do our own methodology that will be suited for automation. So this is our next plan for next year, and maybe on the next confidence, we will talk about threat modeling automated. So thank you for my lecture. And you can rate my lecture on the app, which I encourage you. But also, for all of you, there is a link for my field notes with all the resources that are needed to start the threat modeling and be really, really great at it. So thank you.